All right, Trig, this is section 2.4, other types of equations. The equations that we've been doing so far were all polynomial equations, so like of the form x squared or x cubed or x to the fourth power, and you were trying to solve for x. The main two types of equations that we're dealing with this section is absolute value equations and the square root of x. Okay. There is one problem on the back side of this sheet, the very last one, that talks about radicals ratios, so like x squared over x cubed, and they talk about some guy that looks like that where you have a fraction. We'll talk about what he looks like here in just a little bit, but that's on the back side. So the two main ones that we're going to talk about today are absolute value and the square root. Okay, they start us off with absolute value, and they talk about the algebraic definition. For the algebraic definition of absolute value, if I'm taking the absolute value of c, that is equivalent to positive c or negative c. Those two things are equivalent to one another. So because when I take the absolute value, the negative goes away, c and negative c is what could be inside of that absolute value. I don't know if it's positive or if it's negative. So that's the algebraic definition. In geometry, absolute value is used to determine distance or talk about distance. So if I have the absolute value of negative 3.5, that means if I'm talking about 0, that means 3.5 units on either side of 0. Okay, it could be positive 3.5, it could be negative 3.5. Both of those will have exactly the same value for distance, because both positive 3.5 and negative 3.5 are the same distance away from 0. So absolute value gets rid of that negative because we're talking about distance. All right, properties of absolute values. So they start us off in examples 1, 2, 3, and 4, or these properties, by saying that these things are legal to happen, some other things are illegal, and I'll talk about what those are here in just a second. But in property number 1, it's saying that the absolute value has to either be greater than or equal to 0 or just greater than 0. I cannot have the absolute value be less than 0 because absolute values are never negative. In property number 2, it's saying kind of what I talked about up here, that the absolute value of c is the same as the absolute value of negative c. So when you put absolute value bars around positives and negatives, positive and negative numbers, they both have equivalent values. All right, so that's number 2. Number 3 talks about the multiplication rule for absolute values, and it's saying that if I take two numbers and I multiply them together and then take the absolute value, that's the same thing as taking the absolute value individually and then multiplying them together. An example of that would be like if I have negative 2 times positive 3, and I take the absolute value of that, that's equivalent to negative 2 times positive 3 individually. Okay, both of them are going to be equal to 6. All right. Number 4 is the same rule with the division property. So if I had like negative 4 over 2 and I take the absolute value, that's equivalent to the absolute value of negative 4 divided by the absolute value of 2. Both of them are going to be a positive 2. Okay. Things that are not legal. So these are all legal things. Things that are not legal are like the addition and subtraction examples. So like let's say I have negative 4 plus 2. And I take the absolute value of that, that would be negative 2, but when I change it to absolute value, it would be positive 2. If I do those individually, like negative 4 plus the absolute value of negative 4 plus the absolute value of 2, that actually comes out to be 6. So addition does not work for the properties of absolute values, only multiplication, division, and then those two properties at the top. Okay. The triangle inequality is kind of illustrating this addition property. And it's saying that if I take the absolute value of two pieces individually and combine them into one absolute value, it's not going to be equal. It's going to have this relationship. Okay, they call that the triangle inequality. Here's what the triangle inequality illustrates. So like let's say I have a triangle here, and this is C and this is side D. Okay, this side down here at the bottom has to be larger, has to be bigger than C plus D together. The absolute value of C plus D together. If I put numbers to that, for example, like let's say this bottom side here is 10 and this side up here is 4. This side has to be larger than 6. If it's not larger than 6, like let's say here's 10 and here's 4, and this side is 3, those two sides will not meet each other because 4 plus 7 is, or 4 plus 3 is 7, and those two sides will not match up. So the triangle inequality says that this C plus this D has to be larger than what the third side is together. Okay, that's kind of the property for addition when you're doing absolute values. The square root property says if I take a square root, normally we think of square root like the square root of x squared as being positive and negative, whatever that value is. So like the square root of 4 is plus and minus. Square root of x squared is positive and negative, whatever that x is. So like the square root of 4 would be positive and negative 2. There we go. Let's get some numbers in there, right? Positive and negative 2, they're saying that positive and negative 2 is the equivalent of the absolute value of 2. Absolute value of 2 is positive and negative 2. So whenever I'm taking the square root, writing this is kind of equivalent to writing this, okay? Because I don't know whether this 2 inside of here is positive or negative, so it could be either one. All right. Example 1, it's wanting us to find the absolute value as it applies to distance. So what this question right here is asking is it's saying, find me some x that's 4 units away from 8. Now, if 8 lives here, 4 units away from 8 could be to the right of 8 or it could be to the left of 8. So my answers could be 4 or 12. It doesn't matter which side I'm talking about. That's why x could be 4 or 12 when I'm doing absolute value. Now, algebraically, in the algebra definition, for example 2, to do stuff that's a little bit tougher than what this one is saying up here, what you're going to do whenever you have absolute values is you're going to do 2 cases, like case number 1 and case number 2. Okay, if you've had me in algebra before, we might have done this already, and you're going to think this sounds pretty familiar. But case 1, you just take that guy and you drop the absolute value bars. Okay, you assume that the x plus 4 in there is positive. All right, and then we're going to go through here and solve in just a second. For the second case, that x plus 4 inside of there is negative, and we make it look like this for case 2. Okay, the reason why we do that is because the absolute value of x plus 4 is equivalent to the absolute value of negative x plus 4. The absolute value bars get rid of that negative symbol. So when I'm working backwards and trying to solve for x, I have to consider the fact that one of them is positive and one of them is negative. All right? So if we solve this guy over here, if we subtract x from both sides, 4 equals 4x minus 2. Add 2 to both sides, so 6 equals 4x, and x equals 3 over 2. Okay, x equals 3 halves. All right? Over on this side, if I distribute that negative, there'll be negative x minus 4 equals 5x minus 2. All right? Adding x, I will have negative 4 equals 6x minus 2. And adding 2, I'll have negative 2 equals 6x, and x equals negative 1/3 if I solve that out. Okay? If I went through that a little too fast, go ahead and pause the video or rewind the video and you can watch me go through that again. Now, there was a star here that says check for extraneous solutions. That's kind of a mouthful of a word, extraneous. What that means is check these guys, plug them back into the equation to make sure that they are actually answers, because sometimes they will not be. So if I plug those back in to the original problem, 3 halves is like 1.5, so I can think of it as 1.5. Plugging it back in, I have 1.5 plus 4, and the absolute value of that is equal to 5 times 1.5 plus 2. All right? 1.5 plus 4 is 5.5. 5 times 1.5 is, oh, that was minus 2, sorry, I got that confused. Minus 2. 5 times 1.5 is 7.5. 7.5 minus 2 is 5.5. So that guy checks out, and he is an answer. Woohoo! The second one, if I plug in negative 1/3, I've got negative 1/3 plus 4, and the absolute value of that equals 5 times negative 1/3 minus 2, okay? Negative 1/3 plus 4 is 3 2/3, and when I take the absolute value, it's still positive. But over here, I've got negative 5/3 minus 2, okay? Now, you can already see, we don't even have to put these two together. You can already kind of see that, hey, this positive number is never going to be equal to what I put what I get when I put those two together, because that will be a negative number. So negative 1/3 is an extraneous solution, meaning it's not going to work, and the only answer I have is 3/2 or 1.5 over here, okay? So always plug back in and check and make sure that your answers are going to both be actual answers in your equation, okay? On the back side, problem at the top. Same deal here. We're going to have two cases, but it's going to look a little uglier. So x squared plus 4x minus 3 equals 2 is my first problem, but the second one, I'm going to put a negative in front of it because I don't know whether that quadratic inside of the absolute value is positive or negative. So I have to look at both cases, one being positive, one being negative, all right? To solve this guy, I'm going to move the 2 over, so subtract 2. I get x squared plus 4x minus 5 equals 0. And this guy, when I solve him, actually comes out really nice because I can factor him down by saying, what can I multiply together to give me negative 5? And when I add them, give me 4. It will come out as x plus 5 and x minus 1 equals 0, which means that my answers are negative 5 and positive 1. And that's what I get for the positive side of case 1. Okay? Case 2. I'm going to treat this one a little bit differently than what we did on the front side. You are certainly more than welcome to distribute that negative through for all three of those pieces. That's what we did on the front side. We distributed the negative. But some of you might know that you can do this. Divide both sides by negative 1 to cancel that negative out. And then you've got x squared plus 4x minus 3 equals negative 2. So you can divide that negative to start with, and it makes it kind of nice to have to deal with. So again, let's add the 2 to the other side. So I've got x squared plus 4x minus 1 equals 0. I'm going to put those all together. All right, now, this guy you cannot factor. He will not work out. So let's go ahead and do the quadratic. So negative b plus and minus the square root, b squared minus 4ac all over 2a. Okay. Negative b, my b value is 4, so that will give me negative 4 plus and minus the square root of, if I take that 4 and square it, it's 16 minus 4 times a is 1 times c is a negative 1 all over 2 times a is a 1 again. Okay. If I continue solving him, negative 4 plus and minus the square root of negative 4 times 1 times a negative 1, that's a positive 4, which will make this the square root of 20 all over 2. And then there's a couple more things that I can do. That square root of 20 will break down. He will become negative 4 plus and minus 2 square roots of 5. If you don't believe me, you can check that yourself. 2 square roots of 5 is what 20 breaks down into. And then I can take all three of these pieces and divide by 2. So that will be negative 2 plus and minus just the square root of 5 all over 1, or just negative 2 plus and minus the square root of 5. Okay? That will give me a total of 1, 2, 3, 4 answers, because the plus and the minus are 2 answers. Again, you want to always make sure that you plug those back into the original problem. This is going to be kind of ugly to plug back in, so I'm going to skip that part for now. But plugging those back in would be a good idea to check to make sure that we do have the right answer. So those 4 answers, I think the book, when I looked through the book, all 4 of those answers actually came out nicely, or did work when you plugged them back in. So I'm going to skip that. All right, so that was absolute values. Now this one is a radical, which means that we are dealing with square roots. So things like the square root of x. Radical equations are equations that contain expressions with a variable under a radical symbol. Okay, so the square root of x. Now they're more intricate than the square root of x, like this one down here. It's not just the square root of x. It's a little bit more complicated than that. But the power principle says if both sides of an equation are raised to the same power integer, then every solution of the original equation is a solution of the new equation. However, the new equation may have a solution that's not a solution to the original one. For example, here's what this means. If I have the original equation, this is my original. If I have the original equation, x equals 2, okay, and I am squaring both sides, that would give me x squared equals 4, right? This is my new equation. When I solve that new equation by taking the square root, x not only equals 2, but it equals positive and negative 2. So for my original equation, the only answer I got was 2. For my second equation, I had 2 and negative 2 were both the answer. So keep that in mind that when you square or cube or anything both sides, you may end up with an additional answer that was not actually an answer to your original equation. All right, that's why we have to plug stuff back in. All right, solving a radical equation. When you're solving this thing, here's my radical, 3x minus 11, that's under the radical symbol. And I want to make sure before I do anything with him that he is by himself on the same side of the equal sign. So I want to kick this 5 to the other side by subtracting 5. So I will have the square root of 3x minus 11 equals x minus 5. Okay? Then, I'm going to get another sheet of paper. Sorry, you might have to write small. I'm going to square both sides. Okay? When I square both sides, this 3x minus 11 will just pop right out of that absolute value. On this side, it will be like x minus 5 times x minus 5. Okay, that's what x minus 5 squared means. I should write it with parentheses around it. Okay, 3x minus 11 is going to stay the same, but x minus 5 times x minus 5, if you FOIL, will be x squared minus 5x minus another 5x plus 25. Okay, or 3x minus 11 will equal x squared, if I put these middle two pieces together, minus 10x plus 25. Okay? If I'm writing too fast or going through this too fast, feel free to pause. Let's subtract 3x from both sides, and let's add 11 to both sides. So 0 will be equal to x squared minus 13x plus 36. I'm trying to think of numbers that will factor down. What can I multiply together to give me 36, but when I add them, give me negative 13? It is negative 9 and negative 4. Those would work. So x will be equal to 9 and x will be equal to 4. Right? That's what happens when you take and square that square root. Okay? All right. For right now, I'm going to skip example 5 and I'm going to skip example 6. We can talk about those more on your homework assignment, but I'm going to skip 5 and 6 and go straight down to fractional equations. Okay, fractional equations. These actually come out nicer than what they look like to start with. If I'm trying to solve this guy and he's set equal to 0, what I can do is multiply both sides by the denominator. So 2x squared plus 9x minus 5, I'm going to multiply him and multiply by 2x squared plus 9x minus 5. And some of you guys might already be figuring this out, that when I multiply anything by 0, it's just going to go away. So 6x squared minus x minus 1 will just be equal to 0. That will always happen whenever you have 0 on this side and you have a denominator. It's like the denominator just goes away. We don't care about him anymore, all right? Because when I multiply him to the other side, he will always cancel out with the 0. So really, when you're dealing with fractional equations, all you have to worry about is the numerator. That's it, okay? So we need to break this guy down. I could use the quadratic formula. I'm going to try that factor by grouping, that Cody's method, and see if that will work. So what I do is I take 6 times negative 1. It's negative 6, and I look and see what can I multiply to get negative 6, but when I add them, give me a negative 1, that middle term right there. -3 and +2 will give me -1. So I'm going to rewrite him as 6x squared. Let's go -3x plus 2x minus 1. Again, that middle piece broke down into -3x, +2x equals 0. Okay, I'm going to group, and please let this come out nicely. Yes, I think it's going to. All right, again, if I'm going too fast, go ahead and pause. 6x squared minus 3x, I can take let's take a +3x out, and I'm left with 2x minus 1. And over here, 2x minus 1, there's nothing that I can take out, but you always have to take something out. So we take out a +1, and it's 2x minus 1. These two pieces here have a 2x minus 1 in common. And if I yank that out, I'll have left over 3x plus 1 equals 0. Okay. One more thing that I have to do, set each piece equal to 0. 2x minus 1 equals 0. If I add the 1, 2x will be equal to 1, and x is 1/2. That's one of my solutions. The other one is 3x plus 1 equals 0. And if I subtract the 1, 3x equals -1, and x equals -1/3. That's my second solution. Okay? If you look at my original equation, the highest power of x was 2, which means I should have 2 solutions, and there they are, both of them. 1 solution, 2 solutions. There we go. Okay? That's a fractional equation. Again, that bottom just cancels out as long as this guy over here is 0. Okay? Which he should be for all of the examples that or all of the problems they give to you on your homework. That should be equal to 0. So, there's how you do those. Yeah, that's it.